Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new to my channel, I pretty much do LeetCode style questions, and I try to explain things in the simplest way possible. And yeah, so today we have a pretty interesting problem, right? So let's get into the problem statement really quick. So it says given an array of integers, right, and an integer target, return the indices of the two numbers such that they add up to a target, right? Okay. It says we may assume that each input would have exactly one solution. So we know there's going to be a solution for sure, right? It said we may not use the same element twice, right? It says we can return the answer in any order, right? So yeah, this is a pretty good question. So it's pretty much, we got an example right here, right? We got we're going to be given this array, right? And then we're also going to be given this target. And our goal is to find two numbers in there, right? At two different indices that add up to that target that they're looking for, right? So for this particular example, right, 2 and 7 are the two numbers that add up to 9, right? That's why we end up returning 0 and 1, right? Are you guys following so far? Let's say the target was like 13, right? Then we will return 2 plus 11, right? 2 plus 11 will be the answer, but we will actually return 0, index 0, to represent number 2, the index of number 2, and also the index of 11, right, which is 0, 1, 2. So it will be 0, 2, right? So this is how it is, right? So we need to find those two numbers that add up to that given target, okay? So this example, right, we got an example. So target is 6. Now 2 and 4 are the two numbers that are equal to 6, right? So we return those two index, right? That's interesting, okay? And then we got 3 and 3, the target is 6, right? And we return 0, 1 to represent those two numbers, which is this index and this index, right? It's not 3 and 3, it's not the same index. There's two different index, what I'm saying. That's why we're able to return 0 and 1, right? Because they say we may not use the same element twice, right? Okay, so the easiest way of solving this problem would be to generate all combinations of every pair in the array, right? So this could be done by using a double for loop, right? This for loop, so for each iteration, right, we're gonna loop through all the elements remaining in the array n times, right, which will result in the n squared solution. So I'm gonna show you guys a quick example real quick. Come to my whiteboard, okay? So let me paste in the examples that's given. So as you guys can see, right, so the solution would be, so we know a certain number I, right, I plus another number that's index j, right? So those two different I and j are never pointing at the same element, right? So two different numbers equals to the target. That's what equals to the solution, right? So we see this one, 2 and 7 automatically will return those two things. So let's say the target was like something like 18, right? Then obviously 2 and 7 does not equal to 18, right? So we will search the array for a remaining one. So we search for 2 and 7, right? Not a match, does not equal to target. That's 9, right? So we go on to the next number, 2 and 11, right? 2 and 11 is 13, so that does not equal 11. You go there again, right? 2 and 15 does not equal 18, 17. We one short. So now, once we loop through all the numbers that's after that I, right? Then I gets to move forward to go on to the next number, guys, right? So I move forward, right? So now I move forward. Now we start looping through all the numbers again, right? So we start at I, and I is gonna, we didn't find a solution, right? So now we will return 7 and 11. So it will be index 1, index 2. That will be the solution, right? That will be those two indices that will return, right? So as you guys can see, right, this is not very effective, right? So imagine like if we have had 1,000 numbers, right? And we look, so we were at this number, right? And we look through all the 1,000 remaining numbers, right? We didn't find a solution, and then we have to, so we move I forward by 1, right? And then we need to look through what the 1,000 numbers minus 1, right? And all the numbers over and over again. So numbers that we've seen before. So we'll be going through all those numbers many different times, right? We don't want to do that, right? So let me show you guys the code for this algorithm that I just showed you, the n squared algorithm, right? So as you guys can see, we have pretty interesting. So we have the double for loop. So we got the I, right? That's gonna iterate through. That's a linear one, and then we have another linear one, right? For n elements. You know what I'm saying. So n times n gives you a quadratic, right? N squared. So n times n gives you a n squared solution, right? Which is not too good, right? We can improve. Right now, we're not using any space right now. So there's a better way of doing this, right? So I'm gonna show you. So yeah, guys, the better way of going about this problem will be to kind of introduce ourselves to some kind of data structure, right? So I'm gonna show you guys how I'm gonna go about it. So right now, we know that for every iteration, right? So so let's call the whatever number that we're at I, right? And then we know that nums of I plus some other number is going to equal to the target value, right? So let's say we got 2, right? So 2 plus some other number, right, can give us the target. So how can we know what this other number, right? This other number is going to be the target minus the nums of I, right? We just solve for some of other numbers. So a simple algebraic manipulation, right? So I want to solve for this number. What do I need? So nums of I plus x, right? That's pretty much what this is. So we do nums of I plus, because we know what the target is. We know what nums of I is, right? Every time, every iteration, we know those two variables, right? So now we just need to solve for some other number. Some other number is just target minus nums of I, right? So now, guys, with that intuition, I want us to, start, so now with that intuition that we just got, right, we're gonna look in the data structure every time, right, if we have seen that number before, right? So once we do that, we're gonna do two things, right? If we have seen it before, then we return nums of I plus that some other number that we've seen before, and we return this as the answer, right? But if we have not seen that number before, right, then we just add nums of I to the hash map. The hash map is very efficient in terms of looking up stuff, right? It's constant time lookup, so it's a very good data structure, right? Very efficient, right? It can help us, get the stuff in constant time, so we don't have to worry about searching. You know what I'm saying, just constant time lookup, right? So that really helps us in getting the time complexity of n squared. So right now in the hash map, right, we're gonna store the number and its index, right, inside of it, right? So that every time we look up in the data structure, hey man, do you have, so I'm gonna go through a couple examples real quick, right? So it's a lot more clear, right? So let's say, so the hash map, right? So we got an empty hash map, right? So right now, nums of I, right? So let's say we got let me just, so yeah, let me just copy that example real quick. Bear with me, guys. Okay, cool. So now so right now what we're doing, guys, we're eliminating the J pointer, right? Because we're getting rid of that. You know what I'm saying? Because we want to save space. Space is very important, right? So that's why we're getting rid of it. So we're only using we're only doing a linear loop through. We're only going through all the numbers once. We're not gonna do them twice, one time, right? One pass. So right now, but at every pass, right, every iteration, right, we're gonna ask ourselves. So we're gonna ask the data structure. Do you have? So right now we would ask the map, right? Do you have a 9, right? The target minus 2, right, which is 7. Do you have a 7 in there? No, you do not have a 7 in there, right? So since I do not have a 7 in there, I'm simply gonna put, right? So I'm like, all right, cool. So I'm just put myself. I'm gonna put the number that I'm currently at right now, right? I put myself in there because 2 might be useful for some other number, right? Let's say in future iterations, right, we encounter a 7, right? The 7 is gonna need a 2 for it to be complete, so it could equal to the target, right? So that's why we put it in there for future iteration, because it might be useful for that 7, right? 2 just came too early. 7 didn't appear yet, so that's why we kind of did that, right? So yeah, guys, so we could just keep doing that, and then we move I forward one time, right? And then we do the same things. So it will be 7 plus some other number, right? This other number is 2, right? Since we solved for it, 9 minus 7 is 2, right? So now we look in the data structure, right? And the hash map, does a 2 exist, right? Do you have a 2 in there for me, right? And the map says, yes, I do indeed have a 2 for you. So I return, so I'm like, all right, map, give me 2's index, right? So I return at the answer, right? The answer is going to be, give me 2's index, right? So it's 0, right? Plus, and the current index that I'm currently at, right? The I that I'm currently at. So the I is index 1, right? So we return those two numbers as the solution. So this is the most effective solution, guys. Very, very efficient by introducing some kind of data structure to remember the numbers that we've seen before. We can easily solve this in linear time. So we don't have to keep looping through all the numbers over and over and over again, right? It scales up pretty good. So right now, the way the code works, right? So we just introduced the data structure that I talked about, which is the map of integers to integer, right? Call it map, new hash map. So now, right, so we're going to get rid of this inner for loop, right? Because all right, we know we're going to do it in linear time, guys. So we do the same thing. So we ask, right? So we like int some other number, right? Some other number is equal to the target, right? The given target that's passed minus nums of I, right? The current number current iteration that I'm on, right? And then I look, and I'm like, does the map contain? Do you contain a that other number, right? The thing that's gonna help me make it a match. If you do indeed have that, right, we're gonna return map a new array of map that get some other number. So we're getting the index of that number, I'm saying. All right. So that's gonna return the index and plus the current thing that we're on. And yeah, if we don't end up finding that, right, then we just put ourselves in there, the current number at the current iteration that we're currently on, right, the eighth iteration, and we just put that number, right, that maps to its index, right, so that when we want it, we return that the index, right. So we put the actual number, right, and then we store the index as the value. So the key is the number and the value is the index, right. So very, very important, guys. So let's just press run code. Seems like I messed up somewhere. Yeah, sorry, guys. Press run code. All right, run code went fine. So let's press to check all the test cases. All right, perfect, guys. We were able to pass all the test cases, guys. I want to thank you guys for taking the time to watch this video. And yeah, let me know in the comment section if I did a pretty good job at explaining this question. If you guys have any questions, please leave a comment and let me know. And if you guys are new here, make sure to subscribe because I will be uploading a lot more videos just like this one. So thank you guys for watching, and I'll see you guys in the next one.